In this lecture, we'll have a look at the IV estimator in the case when we have several explanatory variables. So this is the setup for this lecture. We have a linear regression model and we have random sampling. We have explanatory variables from x2 through xk. And for each of these explanatory variables, it may be either exogenous or endogenous. Also, we assume that for each and every one of the endogenous variables, we have an instrument. So if xj happens to be endogenous, then we have an instrument for that variable denoted by zj. For those explanatory variables that are not endogenous, that is for the exogenous ones, then the variable can function as an instrument for itself. The variable itself will satisfy all the conditions that an instrument should satisfy. It's obviously correlated with itself plus the expected value of the error term conditionally on this variable is 0. So by doing this, I have actually now a complete set of instruments from z2 through zk. Some of the z variables are the same as the x variable, and some of the z variables are entirely different. The assumptions on the instrument for this particular case must be the following. They need to be all exogenous. That is, the conditional expectation of the error term given all the z variables must be 0 for every error term. Every z variable must be correlated with every x variable. That is, the covariance between the z variable and the corresponding x variable cannot be 0. And the z variable cannot have an direct effect on yi. The exception obvious when an x variable is exogenous and it functions as an instrument for itself. Then we allow it, but if the z variable is different from the x variable, then it should not be included in the original regression model. So we can view that simply as the conditional expectation of the y variable. If I know all the z variables and the x variables, this will not depend on the instruments at all. If this information is given to us, then we can actually estimate our parameters in the linear regression model using the IV estimator. But just like the OLS estimator, the formula cannot really be expressed unless we use matrix algebra, so we just simply have to trust that it's correctly programmed into one of the software that we are using to compute the IV estimator. So let's see how it's done in Gretel, for example. Let's say that my regression model is as follows. I want to explain wage, the salary, using education. So that's in this variable ed76, and I want to include experience, and let's say that I also want to include a dummy variable which is 1 for Afro-Americans. My assumption here is that education is endogenous. I believe that education is correlated with other factors that affects my salary. But let's say that we believe that experience is exogenous. That is, we do not believe that experience is correlated with the other factors that affects our salary. And the same for the dummy variable, we assume that that's an exogenous variable. So then we can just go to Model, Instrumental Variables, two-stage least squares. We want to explain wage. We want to use as explanatory variables education. Let's move this down. We want to include experience, and finally we want to include the dummy variable. So here's the deal for the instruments. I need to have at least one instrument for every variable. And the point is that all the exogenous variables, I can use the variable itself as my instrument. I believe that education is endogenous, so for education I use mom/ed as my instrument. But experience, I believe that that is actually exogenous, so I can use experience as an instrument for itself. And the same thing goes with the dummy variable. I can use this as an instrument for itself. Now I have as many instruments as I have regressors, and then I can run the regression. And here is the instrumental variable estimator, and as long as I made the correct assumptions about the endogeneity and exogeneity of the explanatory variables, then these coefficients will be consistent. They will not be unbiased, but they will be consistent. The only case they will not be consistent is if I have assumed that the variable is exogenous when it really isn't. In that case, it's not going to be consistent. If I make the opposite mistake and I assume that a variable is endogenous when in fact is exogenous, then the IV estimator will still be consistent. Note that Gretel knows about this restriction. So if I try to explain wage 76 with these explanatory variables and instruments like this, I don't have now an instrument for the dummy variable. Click OK, and Gretel will complain that the order condition for identification is not satisfied. At least one more instrument is needed. And that's correct. The same thing can be done in eViews quite easily as well. Quick estimate equation, set this to two-stage least squares, type up the regression like this: wage 76, constant, education, experience, and the dummy. For the instrument list, note that it has already added a constant, so you don't have to add that. So for education 76, we do mom/ed, then we do exp 76 acts as a dummy for itself, as an instrument for itself, as does the dummy. Click OK, and you have the IV estimator. So finally, let's look at some of the properties of the IV estimator. Unfortunately, you cannot show in general that the IV estimator is unbiased. It will typically have a small bias that gets smaller and smaller as the sample size increases. So if the sample size is pretty large, the bias tends to be very small. The bias also depends on the strength of the instruments. Remember, a strong instrument is one that's highly correlated with its corresponding explanatory variable. The good news is, on the other hand, that the IV estimator is consistent. Also, the standard errors that are reported by all econometric softwares are calculated using a consistent estimator as well. Since you have a consistent estimator of the parameter and you have consistent standard errors, that means that at least when the sample size is fairly large, that all inference will be correct. The level of significance of confidence intervals will be correct. Of hypothesis test will be correct, and the size of the confidence intervals will be correct as well. Now for the IV estimator, it's very difficult to say what a reasonable sample size is for inference to be valid. It all depends on the strength of your instruments. If you have very good instruments, then a pretty small sample size will actually work really well. While if your instruments are weak, then you need a much larger sample size for inference to be working okay. Finally, note that if you use an instrument for a variable that is actually exogenous, then the IV estimator is still consistent. Although in that case it will be less efficient. If a variable is exogenous, you should not use an instrument because it will increase the standard error of your estimators.